So last time we named alkanes and cycloalkanes, but this time we're going to name alkanes with other functional groups on them as well. Remember, functional groups is the foundation of so many things we will do because we're all about reactions, and functional groups are where reactions take place. As long as we can name them appropriately, we can more easily converse between ourselves about different types of molecules, but also with other organic chemists about molecules. So let's start with nomenclature priorities. Today, we're going to name all the functional groups that have arrows beside them. Well, in fact, we've already named alkanes, actually. But the reason I pick out this picture from here is because they're listed in order from highest priority to lowest priority. And everything alkanes, ethers, alkyl halides, and nitros are equal priority. What does the priority system mean? It tells you whether that functional group takes over the root of the name, as an alcohol takes over the root to be an all, or whether it's named as a prefix substituent, like alkoxy, or alkyl, like methyl, ethyl, propyl, etc. The first group we're going to name is alkyl halides. So we will start with common naming of alkyl halides. Remember that gross system of common nomenclature? Yeah. In common naming of alkyl halides, you name the alkyl group, space, name the halogen that's connected. So in this first example, there are 4 carbons all in a line. So that's a butyl. It's an N-butyl. So that's N-butyl bromide. If we go to the next one, we've still got 4 carbons, but the bromine is connected to the second carbon in the line, also known as a secondary carbon. So this becomes sec-butyl bromide. Hopefully you're catching a little bit of a pattern. We got 4 carbons, so it's a butyl, but there's a little fork on this end over here, so it's an isobutyl bromide. And 4 carbons, but as a little chicken foot, this is tert-butyl bromide. That's common naming of alkyl halides. What about IUPAC naming? When you're naming with an IUPAC, alkyl halides are named as a haloalkane. So in this first example, this is chloromethane. Methane because it's got 1 carbon, all single bonds, and there's a chlorine substituted. You don't have to give a number because the chlorine is obviously on the 1 carbon that you're presented. Same thing with the next one. It's fluoroethene. The fluoro does not have to have a number because there's only 2 carbons, and if you're going to give the substituent the lowest number possible, the lowest number possible is number 1. And number 1 is assumed. In the next example, we've got 3 carbons all in a line. So that's how this becomes 2-iodopropane. And the last one up here, it's 4 carbons, so it's a butyl. Nope, that's common. It's a butane, so it's a 2-bromobutane. Common naming, it was a YL space halogen. IUPAC, it's all smushed together with no spaces, and you have to give a number to the halogen substituent. I would like to go through these fairly quickly, so tie a knot and hang on. The numbering down here should go this way, because that gives my bromo number 2 and my methyl number 5. You're just trying to give everything the lowest number possible. 2-bromo, 5-methyl heptane. It's got to be alphabetical. If I number this next one this direction, I have a substituent on number 1 and 2 substituents on number 5. But 1, 5, 5 is better than 2, 2, 7. Well, that's a 6. 2, 2, 6. You're looking for the first point of difference to have the smallest number. 1 is smaller than 2, so you're doing a 1,5,5. This becomes 1-chloro-5,5-dimethyl hexane. These would be 1, 2 substituted regardless of which direction you number. So when they would have the same number regardless of which direction you count, as a last resort rule, you go alphabetically. So that makes my ethyl carbon number 1 and my iodo carbon number 2. 1-ethyl 2-iodocyclopentane. These would not have the same numbering depending on which direction you count. So this is going to have to be 1, 2, otherwise our numbers would be too big. So 1, 2, 3, 4. This becomes 4-bromo, 2-chloro, 1-methyl cyclohexane. Don't you love naming? We just recently talked about types of carbons. This halogen is connected to a carbon that's connected to one other carbon. So this carbon is a primary carbon, making this a primary alkyl halide. This is a secondary carbon, so this is a secondary alkyl halide. This is a tertiary carbon, so that makes this a tertiary alkyl halide. We're going to do quite a lot of classifying alkyl halides by their substituents like this. Up next, naming alcohols. Just like the last examples, there are 4 carbons here. That's a butyl. All in a line, that's an N-butyl. And common naming of alcohols is very much like the halogens, N-butyl alcohol. You tell me the alkyl group and what functional group it's connected to. N-butyl alcohol. Must mean this one is sec-butyl alcohol. Next is isobutyl alcohol, tert-butyl alcohol. And this one, actually, we didn't have an example in the last one, but there are 3 carbons here, but the alcohol's on the second one in a line, so this is isopropyl alcohol. So what about IUPAC naming of alcohol? Because alcohols are up here as a high priority functional group, that means that we have to find a parent chain that contains an alcohol. Additionally, the highest priority functional group has to be given the smallest number possible. So in this molecule and this molecule, the only functional groups we have are alcohol and alkane. So these are fairly straightforward. The numbers have already been chosen from you, aka I took them from your book and they were already chosen in there. So this 4-carbon chain is a butane, but because ane is the last name when you have only a simple alkane or one of these other low priority groups, we recognize we have an alcohol, so it becomes a butanol, O-L, instead of A-N-E. But you have to tell me where in the chain that butane is. It's on carbon 2. So this is 2-butanol. The O-L signifies alcohol. It is not named a hydroxy because it's the highest priority functional group. It's named as an ol, parent chain, suffix name. So you may look at these 2 different ways of writing the name and say, why did you give me both ways? Either one is totally correct, and it's personal preference as to which one you prefer. This bottom one, some students prefer because they think it seems much more obvious that the ol is on carbon 2 of your butane. I often go with this top one because I don't really love pausing in the middle of my word. But 2-butanol, because the butane has nothing to declare, the ol is what we're declaring is on carbon 2. So it's associated up here for something that comes later in the name. Up to you. The numbering for the next example is already written out, so it's a pentane, but it's not a pentane, there's an alcohol, it's a pentanol, it's a 1-pentanol, it's a 2-ethyl 1-pentanol. Or just like before, you can squiz that 1 in between the an and the ol, and in that case you would shove the ethyl and pentane together with no space. Alcohol is the highest priority of things we're naming today, so if there's an alcohol, that has to be in the parent chain. If there's an alcohol, that has to be in the parent chain, and that alcohol needs the lowest number possible because he's the dictator. So in this 3-carbon chain, I know that it has to start number 1 over here because alcohol is there. 3-bromo, 1-propanol. Ditto here. The chlorine has to be carbon number 4 because alcohol has to be carbon number 2. This dimethyl has to be 4,4 because alcohol has to be lowest number possible. What's different about these next examples are the alcohol would be carbon 3, whether you're counting from the left or the right on this example. So when given that choice, you number to give your other substituent the lowest number possible. The alcohol would be carbon number 4 in this example. You number this way to give your other substituent the lowest number possible. That makes this first one 2-chloro-3-pentanol and 2-methyl-4-heptanol. On a ring, the alcohol is going to be carbon number 1, as long as the alcohol is the highest priority group you have. Note in that priority chart that I have given you, that's only a partial chart. It doesn't go above alcohols because we're not naming anything above alcohols today, but priorities above alcohols do exist. So this is a 3-methyl cyclohexanol. You do not have to indicate that it's 3-methyl 1-cyclohexanol or 3-methyl cyclohexane 1-all, because when you have a cyclo, it's understood that the hydroxy, the alcohol, is on carbon number 1 in a cyclo, unless there's another high priority functional group, in which case you would have a different root name anyway. As with all the others, things go in alphabetical order as long as the high priority gets the lowest number possible. So this is a hept, 7 carbons, heptan. It's a heptan 2-all or a 2-heptanol. It's a bromo and an ethyl that are on this chain. And bromo's on carbon 6, ethyl's on carbon 4. Remember, it's not numeric order, it's alphabetic order. I will number these carbons over here and quickly pop up their name. And I will number these carbons down here and quickly pop up its name, because I'm ready to move on to ethers. Common naming of ethers. Not too hard. Name one alkyl group, then the other alkyl group, and then call it an ether. If it happens to be 2 identical groups, you often say di, but not always. If different, you put them in alphabetical order. IUPAC, we say it's an alkoxy, methoxy, ethoxy, propoxy, we'll see. The top ones, I'm going to do common naming. This one over here is 1 carbon, so that's a methyl. Over here is 2 carbons, that's an ethyl. So we put them alphabetically. Methyl, ethyl, methyl, ether. Ethyl, methyl, ether. This is a 2 carbon, ethyl. 2 carbon, ethyl. Diethyl ether. It is sometimes just called ethyl ether. This one over here, 4 carbons in total, but there's a fork at the end, isobutyl. 4 carbons in total, but they're connected by the tertiary carbon, so that's a tert-butyl. Tert-butyl, isobutyl ether. How do I know to put them in that order? This guy with the hyphen in the middle, the tert, does not count in your alphabetization. Yeah, I know. Give me more rules. I would love to learn more rules. Over here we got 3 carbons connected by the middle. That's isopropyl. 4 carbons connected by the secondary carbon in the line. Sec-butyl isopropyl ether. I'm almost done with common naming. 4 carbons all in a line. That's butyl. 6 connected in a ring. That's cyclohexyl. Butyl cyclohexyl ether. Blech. That's common naming. IUPAC says, let's name these substituents as alkoxy. So 1 carbon, that makes this a methoxy. 2 carbons, ethoxy. 3 carbons, not all in a line. 3 carbons connected by the middle, isopropoxy. 4 carbons connected by the secondary, sec-butoxy, tert-butoxy. Hopefully you get the pattern and can name some ethers. That's our only ether examples. Moving on to amines. Amines are also reasonably high functional groups, reasonably high priority functional groups, according to that chart that I provided earlier. These are amines that need a common name, and they're in the same order that the alcohols were presented. Instead of calling them N-butyl alcohol, let's call it N-butylamine, sec-butylamine, isobutylamine, tert-butylamine, and isopropylamine. Yeah, amines. Common naming. Let's do IUPAC. If the amine is the highest priority functional group present, it changes the last name to be amine. So this 4 carbon is a butane, but it's no longer an ane, it's a butanamine. Where is the amine? On carbon 1. So it's a 1-butanamine, or just like an alcohol, you can squeeze the 1 between the an and the amine. Butan 1-amine, 1-butanamine. The parent chain must have the highest priority functional group on it. So it's also true that the parent chain must have the lowest number on the highest priority functional group. So that's how this becomes a 3-hexanamine. But this one has a carbon group also dangling off of your amine that you have not yet accounted for. If it's connected to a nitrogen, you give it a capital N, not lowercase n, a capital N as its, quote, number. So this becomes N-ethyl 3-hexanamine. That ethyl, where is it connected? To the nitrogen, of course. Over here, I've got a propyl, or a propane. So it's a propanamine, a 1-propanamine. But there's an ethyl on the nitrogen and a methyl on the nitrogen. Cite them alphabetically: in-ethyl, in-methyl, 1-propanamine. A couple more examples for good measure, but I'm going to try to be quick. Here's my longest chain. Nitrogen is the highest priority. The amine is the highest priority, so it gets the lower number. Chlorine has to fall in line because it's not high priority. Don't forget in-methyl. There you go. Nitrogen is highest priority. It has to get the lowest number possible, so I'm going to have a 5-ethyl and an in-ethyl. Nitrogen has to be the lowest number possible, so that's carbon number 2 here. Don't forget the N-dimethyl. 2 methyls, where are they? N and N. And the last one down here, we will put some numbers. Carbon number 1, 2. It's a cyclohexanamine. Off of this cyclohexanamine, I have an ethyl. I also have a propyl. Cite them alphabetically, and then give them a number or a letter designation. Got it? Good.